Okay, moving on. Question B. The minimum value achieved by the function f of x equals 9 cosine to the power 4 of x minus 12 cos squared x plus 7 equals how many? Okay, so the thing is that this is a quartic, right? This is a quartic. So you could potentially differentiate and then, put it equal to 0 and you figure out where the minimum is, and then, you could do that, right? So if you were to do that, then you would think of cos x as an apple, right? I normally say this. So f of x equals 9, you think of it as apple to the 4 minus 12 apple squared plus 7. You could think of it like that, right? And then you could differentiate this. So 36 apple cubed minus 24 apple, equals to 0. And you solve for what the apple is, right? That's perfectly fine. That's perfectly fine. But, this is a very special quartic, right? This is a very special quartic. It's a sort of a quadratic in the sky, we normally say in the UK. Yeah. So because you only have the power 4 term and you have a power 2 term. So you think of the power 4 term as squared. Yeah, squared. Okay, so what does that allow us to do? That allows us to complete the square. Yeah, so instead of this differentiation, I would prefer completing the square. Yeah, I mean, you guys could try it out. This also works. This will probably also work. Like you factorize the apple, and then you get a quadratic, and you know what you're doing. Yeah. Just remember, apple is always between 0 and 1. Yes, this is the warning. Warning, because cos squared of x is your apple, right? Cos squared of x always is between 0 and 1, yeah, not negative 1. Careful, from 0 to 1 only. Yeah, so after you differentiate, you find the min and max. You've got to be careful that the apples actually lie within this range, yeah, and you've got to check which one is the max, which one is the min. That's sort of the annoying part, right? So that's why we normally complete the square, yeah, to make it easier. Okay, so let's complete the square here. So what is this? So let me copy this. So 9, what is this? 9 cos squared x squared minus 12 cos squared x plus 7. Okay, so you see this 9 here. This 9 is basically 3 squared, right? This 9 is basically 3 squared, so we could take it inside the thingy. So 3 cos squared x squared, yeah? So the whole thing squared minus, so we want to complete the square, right? So we need the same term here, so 4 times 3 cos squared x. Yeah, so now we have a quadratic in terms of 3 cos squared x, yeah, the whole thing, plus 7. Yeah, equals to, not equals to, just as the function. Yeah? Okay, so now we could complete the square in terms of 3 cos squared x. So remember, this is the coefficient of b, right? This is the coefficient of the x term. So we divide that by 2. 4 divided by 2 is 2, sorry. So this guy squared, and this makes me plus 4, right? This makes me plus 4, so I need 3 more to make the 7 happen. Good. Minimum value, yeah? So if I want the minimum value, this guy must be as small as possible. Yeah? So something squared. What's as small as possible of something squared? 0, right? So you want, do you guys see this? Yes, good. We want that 3 cos squared x minus 2 equals to 0. So we've got to ask ourselves, is that achievable? Is that achievable? So this means cos squared x is 2/3, right? And as I said up here, the apple is between 0 to 1, right? So 2/3 is between 0 to 1, so it's achievable. Yeah, so it is achievable. So, well, thing is, I don't care where it's achieved. Yeah, I don't care what the x is. Don't even try to find what the x is. Yeah, I only care that it's 2/3. That's it. Yeah, so this guy's 0, so bye-bye. So this is 3. Yeah, 0 plus 3 has to be 3. Yeah, so there you are. If today the cos squared x was not 2/3, for example, if it's something else, which is, well, I don't know, let's say this was 4 instead of a 2, for example, say, yeah? Then cos squared x is 4/3, then you've got to be careful. Yeah, then you've got to be careful. The min is here, but it's outside of the achievable range of cos squared x, yeah? So you've got to think about the boundary conditions then. If the cos squared x was outside, yeah? If the minimum was outside, you've got to think of what the boundary conditions are doing, yeah? But fortunately, they didn't try to trick you here. So there you go. Yeah, the answer is 3.